Hi students, let us try to understand the question. From the top of the tower, a ball A is dropped and another ball B is thrown horizontally at the same time. Then which ball strikes the ground first? This is the question. Let us understand. Let us take H is the height of the tower and we have two balls, ball A and ball B. These two balls are dropped and thrown simultaneously at the same time, that is at the same time. For the ball A, which is falling freely or dropped from the top of a tower, we can clearly say that for a freely falling body, u is equal to 0 and a is equal to plus g, because the acceleration is equal to acceleration due to gravity, which is equal to plus g in the case of the ball falling towards the ground. If the ball is vertically projected, then a must be negative of acceleration due to gravity. Here the ball is falling towards the ground, so acceleration a is equal to plus g. Acceleration a is equal to plus g. And next, the displacement s must be equal to the height of the tower, and let us take the time taken to reach the ball A to the ground is equal to t1. And we have three equations of motions. The first one is v is equal to u plus at. Next one is v square minus u square is equal to 2as. And finally the third one is s is equal to ut plus half at square. We will take this expression s is equal to ut plus half at square. S is equal to ut plus half at square, and we will substitute these values in this expression and we get s is equal to h, u is equal to 0 into t plus a is equal to plus g, so half g, t means t1 square. Then we get h is equal to half g into t1 square. By rearranging the terms, we get 2h is equal to g into t1 square. Therefore, finally we get the time taken for the ball A to reach the ground is t1 is equal to 2h divided by g. This is the time taken to reach the ground in the case of ball A. And for the ball which is thrown horizontally or projected horizontally, let us say the u is the velocity required in order to project a ball. For a freely falling body, there will be no initial velocity, so u is equal to 0. In the case of projected body, there must be u, and the velocity vector u can be resolved into two components. First one is ux, the horizontal component, and second one is uy, the vertical component. So u can be written as ux I bar plus uy j bar. Here ux and uy are the horizontal and vertical components. At this point, when the ball is thrown horizontally, there exists only the horizontal velocity, which is equal to u. This value is constant, and the vertical velocity uy must be equal to 0, and the ball is falling freely or the ball is falling towards the ground. So we will take u as uy, the vertical component, because the direction of ball moving is equal to the direction of vertical component. So u is equal to uy, and which is equal to uy is equal to 0, and the displacement s is equal to h as we have taken in the previous case, and finally a is equal to plus g, t1, t is equal to time taken for the ball to reach the ground must be t is equal to t2. Let us assume as t is equal to t2 and substitute in the same expression s is equal to ut plus half at square. Here s is equal to h we have taken here, and u is equal to uy, which is equal to 0. So 0 into t plus half a is equal to plus g. So g into t is equal to t2. So t2 square. By rearranging, we get h is equal to 2h is equal to g into t2 square. Therefore, finally we get the time taken by the ball to reach the ground is t2 is equal to 2h divided by g. So we can clearly say that from these two expressions t1 must be equal to t2. Therefore, two balls A and B reaches at same time. That is, the time taken by the ball A to reach the ground and the time taken by the ball B to reach the ground is equal in this case. Thank you.